Hi everyone. I'm still looking at the Earth and still wondering what might have caused this, but rather whether or not we can take our moon, throw it at this to get this from one single event. And while learning about the physics, I learned about the right hand rule, I learned about other stuff. But I have to wonder, and I'm going to ask in this video, can we tidally lock the moon instantaneously? For those unaware, the moon is tidally locked. One side always faces in towards our planet. We always see this. We're going to come over here. We're going to talk about this. What is tidal locking? You get this wonderful article here. This is from 2015. We're going to look at what they say, what causes this. And now all the major moons of Jupiter and Saturn are all tidally locked. And they're saying this is caused by gravitational interactions between the worlds. And I have to wonder if that's the case. And now they continue on down here. I don't think they actually tell me how long this takes place. They say, like, the moon was spinning rapidly, or whatever, when it was first formed, which they still haven't proven. They make up these fairy tales. See, the same process happened to all the large moons in the solar system. There's a lot of moons. See, over time, the Earth's gravity slowed it down until it stopped forever. Tidally locked. Now they continue on, and this is actually really funny. Say, in the distant future, the moon will stop moving in the sky and hang motionless, visible from only half the Earth. How distant? In about 50 billion years. Long after the sun has died, the Earth and the moon will finally be tidally locked to each other, just like Romeo and Juliet, blah blah blah. And the force of gravity is a powerful thing. Wow, oh man. All the stories they tell, powerful enough to stop a moon in its tracks. Okay. But let's just consider this for a second. We're going to take this number, we'll just say 50 billion years. We're going to go over to a calculator. I'm going to ask the question, how long does it take for the Earth to be tidally locked? I think I used this one because it shows me the zeros. So 50 billion years is our number. 50, 1, 2, 3, 1, 2, 3, 1, 2, 3 billion. We're going to divide that by how, this is in years. For those unaware, we're going to divide that by the electromagnetic force. And how much more powerful the electromagnetic force is than the force of gravity. How powerful is that? We'll ask Michael Steinbacher. Oh, 10 to the 39th or so. You know, at that point it doesn't even matter. But let's just do this. Divided by 1, What did I do? Okay, 1, and that is, and then something like that. How many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. There it is. Something like that. Now, this number is technically in years. So let's try and convert this. Multiply this. Take this number. We're going to multiply this by the number of days in the year. We're going to multiply that by the number of hours in a day. Multiply that by the number of minutes in an hour. Multiply that by the number of seconds in... Okay, so I think we still have... This would be a fraction of a second here. And to ask the question whether or not the electromagnetic force can actually tidally lock our moon in an instant, then we go back to Pangea Earth and we see this. We go back to our satellite map and we see this. Then we go to our right hand rule and we apply this. We go over to the concept of the spark gap. We see that this is flowing in this direction, so the force of motion gets redirected in this direction. And there would technically be a magnetic field in another direction, and what we get, this body, instead of going forward, it converts its forward progression this way. Because we can get a lot of this. We have more than enough of this actually in our equation. We have too much power. We're trying not to use it all. There's a conservation of energy going on here, and some of that energy gets converted into tidally locking our moon, I think. And then more of it gets converted into this. All of this. I'm going to zoom into this. This is actually the resistance of the Earth, it looks like. This is the physical resistance of the Earth. And it kind of stretches almost all the way back around here. In opposition to this. You have this smaller circle, but then you have this, a much larger circle. And these features are very distinct to me. And this is like the continental divide. And this kind of fractures in. But down here, it kind of continues on. This all carries up and in opposition, in direct opposition to this. There's our band. And these are the features of Earth. We're not in denial or anything, are we? Because that's a big circle. I can barely see it on this map. This is really funny, though. 50 billion years. Anyone want to wait that long to see if this really takes place. And this isn't just like a blog. This is phys.org. That's when I see this and I scroll down and read this, it's pretty funny, but it's also kind of sad when they're saying this is the force that allegedly runs the universe, but what's it packing here? You can't even see this number anymore. 1 year. I'm going to close that down because it's pretty sad, but that much more powerful than gravity. And actually, gravity is explained by the electromagnetic force. We're going to get into that. But I still want to talk about the pole flip, because all this kind of comes back here and over to here. When you have this coming in this, and this coming in this, and you're right in the middle of two potentials, and you send one from this, all this amperage is coming into this circuit now, and there's the need to balance these were previously stable. So I think we have more than enough to take this. By now, I would say it's undeniable we can do this in one single event, but under the right circumstance. That's the key here. And when we examine the different possibilities, that's where things really get interesting, because I didn't even mean to explain the pole flip, but I think I do here. Well, in the meantime, well, good luck everyone, and I'll try and make more. Alright, take care.